to radians and radians to degrees. So there's a couple different ways that you can do that. Converting. Okay, so when we convert stuff, you can either set it up as degrees over radians equals degrees over radians, or you can flip-flop it. Oops. Okay, so it could be radians over degrees equals radians over degrees. It really doesn't matter because then we're going to do the cross-multiplying step. You're just trying to set up a proportion, not necessarily memorize a formula to solve it. So let's say I wanted you to convert 5 pi over 4 into degrees. So you'd be like, all right, well, I started with a radian over some unknown degree. And so I know this is going to equal radians over degrees, which the most common comparison we know is pi over 180 or 2 pi over 360. But we can simplify it so the numbers aren't so big. Okay. If I wanted to, I could also have this flip-flop. You could have x over the 5 pi over 4 equals 180 over pi. Does not matter. Okay. So then we'll cross-multiply. So we'll have that 5 pi over 4 times 180. Oops. 5 pi over 4. I wrote 180. So 5 pi over 4 times our 180 equals our pi times x. Okay. Then we can simplify this down, so this is 900 pi over 4. And then if we divide by pi on both sides, we'll see that those actually will cancel with each other. And we'll see that 900 divided by 4 is 225. So that is the equivalent of 225 degrees. When you're using your unit circle, which you're allowed as a note card for this portion of the test, hopefully you recognize that 5 pi over 4 is greater than 1 pi, so this number should be greater than 180. So that'll help you kind of do some of the estimating stuff to get there. The next piece is going to be an arc length question, and you're going to have to do unit conversions because arc length, I will give you this equation. Arc length equals your radius times theta. But the big thing that you're going to want to memorize, or at least remember, is that theta in these formulas will always be in radians. Okay, if it's not in radians, you need to convert it. And I'll give you a hint right now. I will give it to you in degrees. Do not just multiply it by the degrees. It will be the wrong number. So if I give you something like r equals 12 and theta equals 36 degrees. The first step you're going to have to do is convert that from degrees to radians. This is where I'm going to assess if you know how to do the conversion to radians. So you're going to end up with a similar idea. So 36 degrees over some unknown radian is going to equal degrees over radians. So we're going to say 180 over pi. Cross multiply. So we see that we end up with 36 pi over 180. To the best of your ability, leave pi as pi, okay? Especially when we're converting into radians. It's an exact number instead of an approximation, so that's nicer. And then when this simplifies down, we'll see that we end up with pi over 5. Okay. And so for radians, that just looks nicer. Then we can type this into our arc length formula, so we'll end up with 12 times our pi over 5. And so the arc length, given this information, is going to equal 12 pi over 5. Which at this point, you can get a decimal approximation if you want, but you can also just leave it as an exact answer. Okay? Questions there?
Yep.
Yes?
You could have just done, correct me if I'm wrong, could you have just done 36 times pi over 180?
36 times pi over 180. Yes, you could. That's the exact same thing. Pi over 180. We'll get there. Yeah, so if you memorize the formula or whatever, go ahead and use it. But where that formula comes from, just so you're aware, is it's just the proportion. Degrees over radians, degrees over radians. Okay. Cool. All right, so then the next piece is going to be looking at angular speed and linear velocity translations out of that. So the example I gave last period was we were talking it's softball season, so let's talk about a softball getting thrown. Let's say we throw it and it's got 10 revolutions per second. So angular speed, and I will give you this formula on the test as well, is the omega equals our theta over time. Again, remember theta is in radians, so how many radians is a revolution? 2 pi. So our omega in this case is 2 pi times 10, so this ends up just being 20 pi per second. That would be my omega. This would be my angular speed. Then I will ask you to find the linear velocity translated off of that. Okay, so our velocity is going to end up equaling the radius times the omega. And so, for the sake of the softball, we'll say that this thing is about, let's call it a 2-inch radius. So I'll tell you the radius is 2 inches. So we'll have 2 times 20 pi. And this is inches over seconds. And I'm not 100% sure yet. I may leave it simple and just allow you to leave the answer as inches per second, even though that doesn't make a whole lot of sense to most of us how fast that's moving. Or if I ask you to convert it into miles per hour, I will give you the conversion unit for you. So we could say that this is moving at 40 pi per second, which is 120 inches per second, which is 10 feet per second. Okay. Or I'm going to end up giving you the conversion for it, so you'll have to multiply by 3,600 seconds over, I think it's like 360 inches in a mile. And then this will convert you into miles per hour. So if I ask you to go to miles per hour, just so it makes more sense to us, so we're like, oh, that's how fast that's going, I'll give you that unit. Otherwise, I may just have you leave that as inches per second.
So we're going to have those equations, the omega.
I'll give you these 2 equations. Okay. Yep. I'm going to, because I haven't been here for a lot, I'm going to try to give you as many of those notes as possible without having you guys provide a note sheet that has everything on it. So I'll try to make sure I've got at least the formulas written down for you. Abby?
Okay, so when you have to get your omega, what can you multiply the 10 by?
Revolution. So theta. So this is my angle. If I do 10 revolutions, and each revolution is 2 pi, then my omega is 20 pi. So I'm spinning 20 pi per second. That's kind of what's going on there. Okay, so that one will be the angular speed and velocity stuff. Then I'm going to give you a coordinate point on a unit circle. I'll call it like 3/5, 4/5. And then from here, I'm going to ask you to find all 6 trig functions for it, all the values of the trig functions. So I'll ask you to find sine of that coordinate point. I'll ask you to find cosine of this coordinate point. I'll ask you to find tangent of that coordinate point. I'll ask you to find the cosecant. I'll ask you to find secant. And I'll ask you to find cotangent. Okay? So, the big thing you need to remember from here is your coordinate point, x comma y, is the same as cosine comma sine. Okay, this is the big piece. Because now, that just helps you fill in everything. Okay, if you can remember that it's cosine sine, what is the value of sine? 4/5. Okay. What is this value of cosecant? 5/4, because cosecant is 1 over sine, so this is just 5/4. Okay? So then cosine would be 3/5. Good. So then our secant would be 5/3, because it's 1 over cosine. And then tangent is sine over cosine, or y over x, so it's 4/3. Okay. Or it's 4/5 over 3/5, the 5s will cancel. So you end up with 4/5 when you simplify that. Okay, so cotangent becomes 5. Oh, wait, I wrote that wrong. Thanks. 4/3. Y over x. So this is 4/3, and this would be 3/4. Perfect. Okay. Questions on finding the 6 trig functions given a coordinate point? Okay. Cool. Next piece is going to be looking at. I'll give you the value of something like. I'll give you something like cosecant of t is going to equal 2 radical 3 over 3, just because that'll mess with you and you'll freak out. Okay? But what does that look a lot like?
Looks like a triangle.
It looks a little bit like 2 over radical 3. I just rationalized the denominator. Okay? So when you start to see radical 3s and 2s, you're like, oh yeah, that kind of looks like that thing I see on the unit circle a lot. Be like, oh, it's just this. Especially if I give you something like secant or cosecant, because that's 1 over, and we don't like having radicals in the bottom. So you can take this and go, oh, that's just sine of radical 3 over 2. Those are the exact same things. Now you're like, oh, I can go look on the unit circle, and I can see exactly where this is at. And you'll be like, oh yeah, that's right. So sine is my y value, so I'll look at my y values, and I see that there's my sine value, where it's radical 3 over 2, which is 60 degrees. Or you could write it as pi over 3, if you're more comfortable with radians. Okay? And I'm going to ask you for 2 values. Where's the other positive y value? The other side of this. So it's over there, which is at 120. Okay? Or 2 pi over 3 if you want to give it as radians. Okay? You can give it either as degrees or radians. I won't care.
So we'd have to get both those?
Yeah, I will say find 2 values from 0 to 2 pi, so in one rotation, that makes the equation true. And so these would be your 2 values that would make that equation true. Okay? Let's see. Next one's going to be the graph of a sine or cosine function. So I'll give you something like y equals 5 sine of pi over 6t. And I'll say, go ahead and graph that for me. And so big things you want to recognize is that you have an amplitude of 5. Your b value, again, will help you find the period. So this is pi over 6, which you know is equal to the 2 pi over your period. So cross multiply tells me that my period will equal 12. And then I'll ask you to graph this given a certain range, or domain, I guess. So I'll tell you to graph it between like negative 12 and 12 or something. And so in this particular case, that will get you 2 full rotations. Okay? So you'd have something like this. You know this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You know, go from negative 12 to positive 12. And then go find your 4 key pieces in the middle. So in this case, 6, 3, and 9. And then you can just plot those 4 key pieces. So we end up, sine graph will start at 0, 0. There's no shifts up or down. We're going to go to a maximum of 5, back to the middle, minimum of negative 5, back to the middle. We can carry that backwards as well. So from the middle, we're going to go down, middle, top, middle. And then make this a nice round graph. Don't make it the sharp V, okay? Make this a nice sine graph. And that would be the graph I would expect to see. Questions so far? That's the first page, but it's the majority of the test. The backside has a little bit less stuff on it. Cool. Okay, so the next piece then is going to be right triangle trig stuff. So I will give you a triangle. I'll give you one angle. One side length, and I'll ask you to find everything else about that triangle. So I'll give you a table, and I'll ask you to find angle A, angle B, angle C. I'll ask you to find side length A, side length B, and side length C. Okay. I will fill in the ones that I've given to you, so this will already have 40 and 8 written in it. What's the next easiest for you to fill in?
C.
C is?
90.
Good. That then makes B pretty easy, doesn't it? What's B? 50. How'd you find that?
180 minus 80.
Excellent. So we know triangles have 180 in it. 90 of it is going to be at the right angle, so the other two are complementary. So we know those must add to 90. Okay? Then we can use our right triangle trig stuff to find the side length. So I have an angle. I have a side length that's opposite of it. I want to find the adjacent. So O and A gives us TOA. Good. Tangent. So we're going to go tangent of 40 will equal our opposite over adjacent. Multiply by B, divide by tan. So your B value is going to be 8 over tan 40. Okay. Get the decimal approximation for whatever that is. Go ahead, plug that in for B. Same idea. Now I have opposite. I want hypotenuse. So we have O and H. What are we looking for? No. The other thing to make sure is your degree mode. The other thing to make sure is when we're dealing with this, because I'm giving you angles, measurements in degrees, make sure your calculator is in degree mode. If I give it to you in a radian, then make sure it's in radian mode. I think actually I will. I think there's one question. Yeah, your angle of elevation for the cliff is going to be in radians. Then you put it in radians for that one. For these ones, we'll be in degrees. So for C, similar idea, but now we have opposite and hypotenuse, so we want to use sine. So you have the sine of 40 equals your opposite over hypotenuse. So C is going to equal 8 divided by our sine of 40. Okay, so there's our C value. Okay, there's going to be another one where I give you two side lengths, and then you can go ahead and find things multiple different ways. So the other triangle I could give you is something like this, where it would be like, oops, 4, 3, C. Okay, so similar idea. I'm going to give you two pieces of information again, have you fill in the table. In this particular case, there's multiple ways to find C. You can either, it's 5. Good. How'd you find it? Hell yeah. Sabrina. Okay, what did we do?
A squared plus B squared.
So in this particular case, the other thing you guys hopefully know about right triangles is Pythagorean theorem works. So you could use the Pythagorean theorem to help us find what C is. In this case, we end up with our special triangle, the 3, 4, 5 triangle. Okay, so as we work through that, we'll get the square root of 25. Oh, 25. Okay, so C equals 5. Okay, so you could do it that way. The other way you could do it is you have opposite and adjacent for these two angles. So whether you're trying to find A or you're trying to find B, You know the tangent of A is going to be opposite over adjacent, so 3 over 4. How do we undo tangent? Tan inverse, that tan inverse symbol, which is right above it. So our angle is going to equal the tan inverse, which is that -1 thing, of 3 over 4. Okay? That will just give us an angle. Then once you have A, how can we find B? We can subtract it from 90. Good. Or you can repeat this and it'll get you really close. You'll have a little bit of rounding error maybe, but just make sure that your total triangle, no matter what you pick, actually adds up to 180, not like 179.9. Okay? So I would recommend finding one of the angles and then doing B equals 90 minus A because you know that C equals 90. Okay? So that's that triangle sum piece. So we'll keep working through some of those. Okay? Lots of ways to figure out that other triangle. Then you're going to have a multiple choice question. Everybody loves multiple choice. I'm going to give you something that either looks like this one, or I'll give you something that looks like this one. Or I'll give you something that looks like this one. Okay, so the graphs you could see will either look like this, and you'll have to tell me what it is, or it could look like this, or it could look like this.
What do we have to do? We just have to
And then I'll have 4 equations. It'll say tangent, cosecant, secant, cosine, sine. And you'll have to pick one of those 5. Are any of those a sine or cosine function? No. Okay, that looks totally weird. Hopefully you know that. Now it's no longer a 1 in 5 guess, it's a 1 in 3. Okay? So the next piece is, if it looks like this, what type could it be? Either secant or cosecant. The way to find the difference is plug in the graph that should fill this empty space. What's that green graph look like? Sine. So that graph, the purple, would be cosecant. So sine and cosecant go together, right? S and C's, they get flip-flopped for...
Yes.
Yep. So this would be cosecant. This one would look more like this, which the green graph looks like cosine. So this graph would be secant. Perfect. Okay. This graph is tangent. Good. Cotangent would just be shifted over 90 degrees from it. Okay. But I'll give you one of these 3. Cotangent would be the exact same, but the only difference would be it will look. Actually, this is. It'll look like that.
So it won't start halfway.
It won't start in the halfway spot. Because the difference is you have sine over cosine. So every time cosine is 0, that's where you have the asymptote. Cotangent, you flip it, so it's cosine over sine. So every time there's a sine equal to 0, that's where you have those asymptotes. That's what those get created. So there'll be a multiple choice question on that one. Then I think the hardest question of the test is this one. I'm going to have a temperature question. So there'll be a high temperature of, let's say, 72 degrees today. And a low of, let's call it 58. Okay, I will tell you that the high occurs at 3 p.m. so that you know what time it occurs. And the low will occur at 3 a.m. Okay, this is where I'm going to put in the horizontal shift piece. Okay, is this 3 p.m., 3 a.m. idea. Okay, so I will give you a hint that you should put this in some sort of form of A cosine bx or bt minus c plus d. I will give you that at y equals. Okay. And so I will give you the hint that you're going to want to use cosine for this one. Okay? And then I'll also tell you that t equals 0 corresponds to midnight. Okay, so this will be a 24-hour clock essentially. Okay, so 0 is midnight, 12 is noon, 15 would be 3 p.m. Okay, so hopefully it's a little bit more standard for you that way. So as we go to build this, we'll see we have a high at 72. We have a low at 58. You're going to want to find the average temperature of the day, which in this case, if you add those together, you get 130 divided by 2 is 65. Okay, so our amplitude in this case is 7. Good. My period is, well, the period is 24. The B value is pi over 12. Good. Okay, and then we can plot these points. So I know that we're going to go to 24. Okay, here's the tricky part. Okay, because we're going to deal with 3 p.m. and 3 a.m., everything's going to be shifted slightly. So our normal 4 points we want would be 6, 12, 18, 24. Okay, because we want to deal with 3 p.m. and 3 a.m., we're going to actually deal with the in-betweeners on these. Okay, so you're going to deal with 3, 9, 15, 21, and 27. Okay, because we're going to shift this thing 3 hours basically. Yes?
We don't do the green numbers, and we just put like 6, 12, 18, 24 because that's technically our period.
That's our period, but you're going to want to see these specific spots. So when you go to plot this at 3 a.m., we're at 58.
If we were to just do the...
I'll probably only take a point off. If everything else looks good, you're pretty close. Okay. And then at 9 in the morning, we'd be at the average temp. At 3 p.m., we're at our maximum. Back at 9 p.m., and then back at 3 a.m. the next day. Okay, so now we have our key pieces. This is where hopefully we should see this looks a lot like a cosine graph, which is why I'm going to suggest you using a cosine function. Okay, and we're shifted 3 units towards the right. So I can see that this vertical shift is 3 units to the right, and that my horizontal shift is my average temperature, which is 65. Now I have all of the pieces. This equation can be written as y equals, is this a positive or negative cosine? Negative, good. So this will be negative 7 cosine pi over 12 x or t or whatever, and then minus 3, there's our horizontal shift, plus 65. Now we have our full function. Okay, that'll probably be the hardest question on the test. Okay. Last question on the test in the last 2 minutes here is going to be a cliff question. So I will give you something where I'm like, hey, here's a cliff. How tall is that cliff given you're 40 feet away and your angle of elevation is, and this is the one I'm going to put into radians. So it'll be something like 3 pi over 5 or something. Oh, no, that doesn't make sense. That's too big. Let's call it 3 pi over 7. It'll be something. It won't be quite that ugly. It'll be a nicer number. But I'll give you the angle of elevation.
3 pi over 7.
Yeah, that's kind of ugly. I'll give you something that's nicer. It'll be somewhere between 30 and 80 degrees. Okay? But it'll be in radian form. And so you don't have to convert it. You can leave it. Just make sure you switch your calculator into radian mode. And then we end up with opposite, adjacent, so tangent of whatever that angle is. In this case, 3 pi over 7 equals our opposite over adjacent. And so we'll multiply both sides by 40. That's our x value. Just make sure you're in radian mode. Okay?
Can you do it the other way?